Can you find the area of the shaded portion? Welcome back to my channel. I don't know why I'm smiling too much today. Okay, we are asked to find the area of this shaded portion. Now, this actually appears to be very tricky or very difficult, but it's actually very easy. First things first, we are told that, please, this is not drawn to scale. As you can see, this is just a square, a rectangle, and the area of the rectangle is 4 centimeters squared. This is the only information given to us, meaning that all the things we need must come from here. So first of all, area of a rectangle is length times breadth, right? So if we should call this A and call this B, so it means that A multiplied by B should give us 4 centimeter squared. Okay, now since that is the only information we have, we just have to find a way to use this information judiciously and use it to get the area. Okay, remember that the opposite sides of a rectangle are equal. So this should be equal to this, and this should be equal to this, okay? So it means that this side is also B, and this side is also A. Now this is a quarter circle, right? This is a quarter circle. All right, and since this is a quarter circle, this place should also be A, because both sides are the radius of this circle. All right, now I think everything we need is here already. Yes, like I said, it's very simple, but if you don't look at it very well, you may think that it's very difficult. You are welcome back to my channel. If this is the first time you are seeing us, please subscribe to the channel, turn on your notification bell so that you don't miss our amazing videos. Yes, we upload our videos as often as possible. Do tune in at your convenience. There must be something new for you to watch by God's grace. All right, please comment. Tell us what you feel about this video in the comments or on the comments. Now, back to what we have. We are asked to find the area of the shaded portion. By looking at this, you will believe me that the area of the shaded portion, let area of the shaded portion, let the area of the shaded portion be equal to capital A. So let's use capital A for the area of the shaded portion, okay? Now let us analyze what A should be. Now looking at the diagram, it's obvious that to get A, we need to get the area of the big semicircle, this big one. The area of this big one, okay? Let's call it the first semicircle, because unfortunately we have 3 semicircles. So we need A1, let's call this A1. Right, and we need the area of this smaller circle, this smaller one, let's call it A2, and we need the area of this smallest one, let's call it A3. Okay, so to find A, which is the area of the shaded portion, is going to be the area of the shaded portion, which is A, will be equal to area of this whole semicircle, which is A1, minus A2 minus A3. All right, so the big question now is, how do we find A1, A2 and A3? First of all, area of a circle is equal to pi r squared, but since these are semicircles, the area of the semicircle, let's call it AS, should be pi r squared divided by 2. So for A1, remember that the whole diameter from here to here, maybe we should call this capital, let's call this X. This, no need for that, okay? So since from here to here is B, from here to here is A plus B, right? So from here to here is A plus B. It means that the radius should be half of A plus B. So for A1, the radius is A plus B divided by 2. That is the radius of the big semicircle. Now the radius of this particular one, the smaller one, which is A2, the radius will be equal to, we are talking of this, from here to here is B. So the radius should be B divided by 2. It should be B divided by 2. That should be the radius of this one. Now the radius of the smallest, since from here to here is A, the radius should be A divided by 2. So R is A over 2. Now remember that area is pi r squared divided by 2. Okay, so that means that, remember that this is our formula. A is equal to A1 minus A2 minus A3. So let's bring it in here. So now we have A, which happens to be the area of the shaded portion, will be equal to A1, which is this, right? Minus A2 minus A3. Now A1 will be pi times, the radius is what? A plus B over 2, all squared, right? Divided by 2. Okay, minus this will be pi bracket, this will be B divided by 2 all squared, all over 2 as well. All right, now this one too will be pi, the radius is A over 2 all squared divided by 2. So if we solve further, we are going to have, I'm going to clean this now so that I can have space to solve this. Because if we go further, A will be equal to the first part, okay, now the first yeah, the first part A will be equal to pi bracket A plus B squared over 2 squared, right? A plus B squared over 2 squared. All right, everything divided by 2 as well, minus this one will be pi bracket B squared over 2 squared, everything divided by 2, minus pi bracket, this will be A squared over the same 2 squared, sorry, this is 2 squared, 2 squared, 2 squared, divided by 2. This is our A, right? So A will be equal to pi bracket A plus B squared is actually an algebra identity that states that A plus B squared is equal to A squared plus 2AB plus B squared. All right, that is this for this, over 4, because 2 squared is 4, all over 8, minus this is pi B squared over 4 over 2, and this is pi A squared over 4 over 2. Okay, don't worry, this is coming to an end soon and you'll be amazed at what our solution is. Okay, so the area is equal to, we are going to open this bracket, or let's bring these things down. All right, so this same thing as pi bracket A squared plus 2AB plus B squared divided by, this will be 4 times 2, 8, right? This is coming down because if I choose to change this division to multiplication, for example, if you have A over B over C, right? It is the same thing as A over B. If I change this division to multiplication, I'll take the inverse of the denominator as 1 over C. So that is why if I want to remove this division, I will multiply this by 1 over 2, which will give me this times over 8, right? Yeah, so that is exactly what I did there. So moving forward, same thing will happen here. We have pi B squared over 8, and here we have pi A squared over 8. All right. So now we have A is equal to, let's open the bracket, pi A squared plus pi 2ab plus pi b squared. Okay, now minus pi b squared minus pi a squared, everything over 8 since they share the same denominator. Now let's see if there is anything we can cancel out. So pi a squared minus pi a squared, pi b squared minus pi b squared. So now we have the area as pi 2ab over 8 or 2ab pi over 8, anyone. Now 2 will divide itself, 1 divide 8 to give us 4. So we have, this implies the area is pi ab over 4. Now, but AB is 4. You can see that AB is equal to 4, right? Let me call it so that you see it very well. So you can see that AB is equal to 4. So as a result of that, we can write that our A is equal to pi AB, that is 4 pi divided by 4. Now this will remove this, it means our area is pi unit squared. Thank you for watching, and I wish to see you in my next video. Bye.